Welcome to section 4.4, day 3, the quickest route. Our objective today is to use optimization strategies to determine the quickest route to reach a destination. Troy dives off a dock into the Mississippi to retrieve his frisbee and is swept 100 yards downstream by the current. He is now 40 yards offshore. He can swim up the river at 3 yards a second and run along the beach at 8 yards a second. Where should Troy land in order to reach the dock in the least amount of time? When we have problems like this, it is very, very helpful. It's almost impossible to do without drawing a picture of the situation. Here we have our Mississippi River. Here is our dock. And Troy is out here in the water because he got swept down river from the dock. He is 40 yards from the shore. He is 100 yards downstream from the dock. All right, there are two things that Troy can do to get back to the dock. He's either going to be running along the beach or he's going to be swimming in the river. So Troy is going to try to land somewhere along the shore. He could swim all the way back to the dock. He could swim straight to the shore, the 40 yards, or he could land somewhere between the shore straight away from him and the dock. So we have a couple of different distances, and this one I'm going to call X. From where he is, 100 yards away, this is the distance X, and this remaining distance here is our total distance minus X, which is 100 minus X. This is my hypotenuse. I'm going to call it C. All right. So there's my drawing that will help me solve this problem. And it says we want to do the least amount of time. Well, what he's doing is of our formula D equals RT. So we're going to rewrite this for time because we're trying to find something with time. And that's going to be our distance divided by our rate. And remember, he can do 3 yards a second for swimming and 8 yards a second for running. So now we're going to see what our distance in the water would be. So we have our hypotenuse C. So we'd have C squared equals X squared and 40 squared. When we do this, we get C squared equals X squared plus 1600. And if we solve for C, we get X, the square root of X squared plus 1600. So that is my distance in the water. Our distance on the land is 100 minus X. So we figured out our distance in the water, we figured out our distance on the land, and we're trying to find time. So to do these, we have to take our distance. For our time, we take our distance divided by our rate. So our t function, t of x, is our distance in the water, which is square root of x squared plus 1600. We're going to divide that by our rate, and our rate is 3 yards a second. Plus our distance on the land, 100 minus x, over our rate on the land, which is 8. This is my setup. We can make this a little easier to look at by, or at least a little easier to do our derivative from. We say this is 1/3 x squared plus 1600 to the 1/2. And this is plus 100 over 8 minus x over 8. Makes it a little easier to do the derivative sometimes when you do this. And then we have our derivative, our t prime of x. To take the derivative, we have our 1/3. We're going to have to use the chain rule times 1/2. Our parentheses, x squared plus 1600 to the negative 1/2 times 2x. All right, that's the derivative of our first part. The derivative of 100 over 8 is just 0. And the derivative of negative x over 8 is minus 1/8. All right, so there is my derivative. We're going to set this equal to 0. And when we do this, when you set it equal to 0, I'm going to do a little shortcut here. We would get, we're going to combine all this thing together. We'd have 1/8 equals 1/3 times 1/2 times 2 is 1/3. And then in the denominator, we'd have our square root of x squared, x squared plus 1600. That's in our denominator. And then in our numerator, we would have our x. Because 2x times 1/2 is x. All right, so there is my, as we set it equal to 0, and I'm going to solve it for x. I'm going to do this by cross multiplication first. So we have 3 square root of x squared plus 1600 equals 8x. I'm going to square both sides. We get 9 x squared plus 1600 equals 64x. Going to multiply in. We get 9x squared plus 14,400 equals 64. Oh, this will be an x squared here. 64x squared. We'll get the x squareds on one side, and we get 14,400 equals 55x squared. And I am running out of room. We'll do it up on the top here though. And when you solve this, you're going to have x squared. So I'm going to move it all the way up to the top here. Equals 14,400 over 55. And you take the square root of both sides of this. And when you do this, you're going to get x equals 120 over the square root of 55, which is 120 square root of 55 over 55, which is 24 square root of 55 over 11. So this is my x value. This is my critical point for this problem. And if we took the negative side of this, it wouldn't make sense because we can't have a negative distance in this problem. So we have 24 square root of 55 over 11, and this is in yards. What we have to do now is test our endpoints and our critical point to see which way is going to be the least amount of time. So I'm going to have to erase some of this down below so we have room. And I'm going to erase the derivative piece so I have some room I can work with. This is a very long problem. So now we're going to test, and if you went straight to the shore, our x would be 0. If you went straight all the way to the dock, you'd have x is 100. So we're going to test the points 0, 100 for our endpoints, and then 24 square root of 55 over 11. If you take t of 0 and you plug it into our formula that we have, you will get that this goes to 20, our time is 25.833. If you plug in our other endpoint of 100, where you go straight back to the dock, you will get 35.901. And if you take the time of 24 square root of 55 over 11, you'll get a time of 24.860. So when you look at those three times, this is the smallest time. So our land is going to be at approximately 16.181 yards. So 16.181 yards from where he is at in the water. So he's going to swim upstream. Our X value here is 16.181 yards. When you do these type problems, the shortest distance, strongly recommend that you use and draw a picture. It will help you visualize what is going on. And just like we did the other day, quite often you will have to write one of your formulas in terms of another variable. And there's your assignment. Notice it's only 3 problems because there are problems just like we went through, and they do take a little bit of time. Thank you for watching, and have a nice day.